All right. So integer exponents. We're going to be working on those today. And oh, Gavin's on. Awesome. All right. So here we go. With integer exponents, we do the warm up for the day, which will be from the other day. 10 to the third means what, Christine? Wonderful. Well put. So 10 times 10 times 10. And when we do that, we get 1,000. 10 to the first, we take that 10 one time. All right. Now they do that one for a reason. 10 to the first should be 10, not 1. They made a mistake. Okay. 10 to the first is 10 because it says take 10 one time. All right. 10 to the fourth says what, Bruce? Oh, Bruce isn't here. What says what, Connor? 10 to the fourth says what, Connor? Whew, we got some craziness going on there. 10 four times, and then we get 10,000. 10 to the fourth, we get 4 zeros. 10 to the fifth will be 5 zeros of 100,000. Makes 10 times itself 5 times. And 10 to the sixth is a million, 6 zeros. All right. 2 different ways. Good job, crew. All right. Learn to simplify expressions with negative exponents and to evaluate zero exponents. Negative exponents and zero exponents. Now, the zero exponents, that I can tell you what it always is. Negative exponents, well, we got to focus on that a little bit more. All right. So we just kind of saw. I'm sorry, just a second. All right. We just kind of saw what 10 to the fourth, first, all those are. But here's kind of a chart that maps it out 10 to the zero. So anytime I have like 10 to the first, I could have taken that times 1, and that doesn't change a thing. If I had 10 to the second, I could have taken that times 1. That didn't change a thing. When I have 10 to the fifth, when I take out 10 times 10 times 10 times 10, oh, they're getting worse as we go, times 10, I could have added a times 1 on there to those, Haley, right? When I add a multiply by 1, it doesn't change a darn thing. You need to leave the room. Leave the room. Sorry, guys. My children are deciding not to be quiet today. All right. So, when we multiply anything times 1, it doesn't change it. So, 10 to the 0 means we have 0 tens. But even if we take away all these tens, we're still kind of left with that 1 that is always there, right? So, anything to the 0 power, anything to the 0 power is always and forever 1. Even like -7 to the 0 power, that's 1. All right. Then the other thing that we notice, I want you to look at this one 10 to the first, 10 to the negative first. How are they alike, Lucas? How is 10 to the first, 10 to the negative first? How are they alike? Right. What's the difference in them, Lucas? Right. That's very well put. So it's 10 one time, okay? This one is 10 over 1, right? This one is 1 over 10. So these are kind of, what's that word? It starts with an R. We use it when we're multiplying or dividing with fraction. It's, ooh, what was that again? Say it again. Nice job. So when we see that negative exponent, it's like saying there's a reciprocal, okay? So what I always tell my students is think of it as, 1 over 10 to the first power. Whenever you move it from the top to the bottom or the bottom to the top, you get rid of that negative and then you can do everything as normal, okay? So when we look at 10 to the second, Carson, and 10 to the negative second, all right, how are they alike, Carson? They did both put 10 twice. How are they different then, Gavin? All right, Carson, we're coming back to you. Gavin's still working on waking up. All right, so Carson, go ahead and tell me how they're different then. All right, now Gavin, specifically for you, do you see how if I put that over 1? Oh, it's like the reciprocal of this. Okay, so that's kind of an important slide there. You can kind of see that. But the other thing that I said, 10 to the 0, anything to the 0 is always 1, 1, 1. Okay, so we look for a pattern. Oh, each time we go over, it's a dividing by 10. Or if we go the other way, it's a multiplication by 10. It still continues with that same pattern, but they're there. So with this one, write in decimal form. So to write it in decimal form, we first need to write kind of in fraction form. So I always think in 2 steps. So I have a negative here. So if I always write this with a 1 over it, does that change anything, Carson? No. So Haley, then when I take this, my first step is going to be, okay, I'm going to leave a 1 at the top, and to get rid of this negative 2 exponent, I'm going to bring it down to the bottom. When I go across that division line, it goes from a negative to a positive. It switches signs, okay? So 1 over 10 to the second, or what's 10 to the second, Haley? 100. Perfect. All right. What is 1/100th as a decimal, Haley? 1/100th. How do I write that as a decimal? 1.00, 0.01, 0.1. How do I write that as a decimal? 1/100th. Jacob, help her out. 0.01. Remember how we say the hundredths place? Tenths, hundredths. Is it coming back, Haley? Yeah, okay. All right, that'd be another one. All right, so then on this one, Natalie. All right, so the first step I'm going to focus on is I'm going to focus on 1 over 10 to the first. Since I brought that down, Connor, that negative is gone. So, Natalie, what is 10 to the first then? 10. So 1/10, how do I write that as a decimal? 0.1. All right. Now we're dealing with tens. Those are pretty easy. I'm thinking you guys are probably feeling pretty good about this. Their stuff matched up with our stuff. Their stuff matched up with our stuff. All right. And we're pretty good to go. All right. Now, as we get here, we want to remember our rule. What is the first thing, Christine, that I'm asking you guys to do? The first step that I'm asking you guys to do. Okay, so we know it's 10 to the negative 8th over 1. So what's that fraction look like, Christine? Not to the negative 8th, to the positive 8th. Right. So I've been telling you once it goes across that fraction line, it switches signs. The other thing, when you look at these, Christine, do you see how this one and the one you just wrote, those are reciprocals, right? Yeah. So it's kind of a way of saying take the reciprocal of this number. That's another way we can think of it if that helps some of you. All right, Christine. Now, it says write in decimal form, but first let's write it in a fraction form. 10 to the 8th. I should have a 1 with how many zeros behind it? That a girl. All right, so there we go. All right. So 1 over 100 million or 1/1,000,000th. Oh, man. Tenths, hundredths, thousands, 10,000s, 100,000s, millionths. I should put a 1 in the millions, shouldn't I? All right, so let's make that into a ugly old 1. All right, that's a 1. Okay. All right, so that's how that one would look there. All right, just a second. All right. So let's see if they match up with Christine. So 1 over 10 to the 8th power. That looks very good. That's exactly what she did. We did the multiplication, 1 over 1 million, 100 million, excuse me. And, oh, I did not write enough zeros, did I? Okay. And as I move this and I move that, you can see 1 to the 1 millionth. All right. So I'm going to have to do one change here. All right. And as we go on, now this one, crew, I haven't got to you yet this time. So what do I need to do, crew, if I'm going to have you do it my way? Uh-oh, did we lose crew? Okay. So let's look at this, crew. First, we have a fraction here. Do you agree? If I put it over 1, it's a fraction, right? Now, we want to make this fraction different. That negative always tells us, hey, this is going to be, we're going to do the reciprocal of this. So what is the reciprocal of 10 to the negative 9th over 1? Okay, 1 over 10 to the 9th. Good, good, good. So now we keep a fraction here, right? And that says 1 over 10 times itself 9 times, right? Okay, so I'd have a 1 with 10 zeros, or 9 zeros behind it. Yeah, okay. So now that's 1/1 billionth. Ooh, it's a small number. So when I do my decimal, I'd have 0, and then I have tenths, right? Hundredths, thousandths, 10,000ths, 100,000ths, millionths, 10 millions, 100 millions, billions. Do you see how we kind of counted those places out, the place value, crew? That makes sense. All right. Sometimes it helps to walk through them. I do know that. All right. So when we've done all that, um, let's just make sure 1 times 10 to that, and we're good to go. When we do this, do I have the right number of zeros? All right. So they counted theirs out. They got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Woohoo! We did do it. All right. Now, we've done everything with tens. Now we're going to jump into other stuff. Negative exponents. I always like to look at this middle one with numbers. Do you see how the very first step, Lucas? It is write it as a reciprocal, because that could have been 5 over 1, right? Yep. And then you just do the normal stuff. The 1 stays on top because there's nothing that is cubed on top, and the 5 is cubed. That makes 125, doesn't it? All right. So this page is a good page to take a snap of, or it's right in your book. Okay. So as we move on here, this first one, Trenton, as I come to you, sir, the first thing that we do, I always think of it as, okay, it's over 1. So I have 5 to the negative third over 1. What's the reciprocal of that, Trenton? 1 over 5. Now there's something important you need to bring with the 5. 5 to the third. Very good. And since he went from top to bottom, it stays positive. Everything else stays the same. So that means 1 over 5. Oh, that's an ugly 5. Times 5 times 5. Do we all agree? And then 1 over 125 when I multiply all those out, right, Connor? Bruce joined. All right. All right. All right. Let me let his mom know he's on. Got him. All right. All right, so very good. So we've got that from Trenton. Trenton did pretty well with it. So there's just an extra step to be had. All right, Bruce, as we're doing all these things, we're trying to go. Just a second. All right, so now, Michaela, I haven't had you with me in a while. So, Michaela, I want you to think about this as a fraction. So, being that there's a negative exponent, it's like we're doing the reciprocal. What's the reciprocal, Michaela? I'm sorry? Okay, so negative 3, that's the exponent, right? So this whole thing, I want you to look at this whole thing. What is the reciprocal of that whole fraction there that we made, Michaela? Okay, that's the fraction, is the negative 10 over 1. Now I need to do the reciprocal, the flipping of it. Okay. So okay, so let's do this. There's 3/5. Here's the reciprocal of 3/5. All right, Michaela, that I wrote the second one. Okay. So do you see how I wrote the reciprocal this fraction, and then I change it to the reciprocal there? Okay. Now I have this fraction. Do you see that fraction? How do I do the reciprocal of that fraction, Michaela? 1 over -10. And that exponent still comes with it, and it's 3. It's positive now. Okay. The negative in the exponent, guys, is like telling us take the reciprocal of this problem. Okay. So, Michaela, you did that very well. And so that means 1 over -10 times -10 times -10, right? Oh my gracious, ugly handwriting. Okay. So when we take -10 times -10 times -10, 3 negatives, is that going to be a negative answer or a positive answer? Nice job. Very nice job. And 10 times 10 times 10 is a 10 times. But how many negatives are there? If there were two negatives make a positive, so that'd be uneven is negative, even is positive. All right, good, good. Yep, very good, very good. And 100 times -10, Michaela was telling us, was -1,000. Good job, good job. Good questions, Lucas. Thank you for dealing with the interruption so well. And Lucas, anytime anyone else has a question, go ahead and jump in like that. We'll make it work. All right. So, Bruce, as we kind of jump on, I'm going to try to get you involved here real quick. All right. And they did exactly what Michaela said, and we've got our answer. Now, I don't always need to see them as decimals here, but we're good to go. All right, Bruce. So we're always going to pretend like this is a fraction right from the get-go. And then, Bruce, because there's a negative in the exponent, we're going to do the reciprocal of that. So what is the reciprocal of this fraction I've written there, Bruce? All right, Bruce, you didn't do the first step with us. What is the reciprocal of this fraction? That was my question. Okay, so Bruce, 3/5, that's a number we have, right? The reciprocal of 3/5 is 5/3. Do you agree? So the reciprocal is literally taking it and flipping it. So now that I have a fraction here, this negative in our exponent, that tells us that we take the reciprocal of the fraction. So what is the reciprocal of this 4 to the -2 over 1, Bruce? All right. Now, 1 over 4. The only thing that changes there is now instead of being -2, it's to the +2. When they go across this division line here, the fraction line, it changes. Okay, Bruce? All right. All right. Very good. So then we do everything you said. So then we do 4 times 4, right? And I don't need to see this step necessarily. So that'd be 1 over 16, wouldn't it? Okay. So our answer is just slightly different than yours. All right. So Connor, now I'm jumping to you, sir. All right. I am recording, yes. All right. So everybody's seeing this, so I'll have videos up later. So Connor, we're going to see this, and Gavin, you're coming next, so make sure you stay awake. All right. So we have -7 to the -4th power, Connor. So what's our first step, Connor? All right. 1 over -7. Now, the exponent, guys, when the exponent goes down, it doesn't stay negative anymore. When we bring it across, it stays positive. Then we can't deal with a negative exponent, so that's why we move it first right away. Okay? So 1 over -7 to the 4th. When that exponent goes down, that negative goes away. It switches, okay? So then We have 1 and -7 times itself. How many times, Connor? 4. All right. Now, -7 times itself 4 times. Are we going to have a positive answer or a negative answer, Connor? Okay. Now, Lucas said something very interesting earlier. If there's an even number, it's positive, because -7 times -7, that's 49. Oh, my gracious. All right. Then -7 times -7 is 49. Sorry about my bad handwriting. Then 49 times 49. Somebody jump on that for me. Thank you, Carson. 2,401. All right. And then that is our answer. So, Bruce, Connor, Gavin, first step, turn it into that reciprocal. Second step, all right, we got an even one, even though it's a negative, we got an even exponent, so we know it's going to be a positive answer. Then just do whatever it says, because when you bring it from the top to the bottom, the exponent becomes positive. All right, so let's look at what they show us. All right, they did that exactly what they did. I really don't like that they didn't put parentheses around it. But we get 1 over 2,401. All right, now here's another page that shows us everything we need to know. And I always focus on the number part, especially with you guys. 100 to the 0 is 1. -7 to the 0 is 1. Anything to the 0 is. Somebody help me out. 1. Good job, good job. Anything to the 0 is 1. Always and forever. So if it's a negative exponent, you do the reciprocal of that, then you do all the work. If it's a. Yes, sir. Okay. 7 over 7 to the first power, you mean? Okay. So 7 to the first power means how many times? Just 1 7. So the answer would be 7. Does that make sense? Yep. And 7 to the second power means 7 times 7. 7 to the 0 means no sevens. So if I don't write anything here, it's like there's that understood 1 that always pops up, okay? So anything to the 0 power is always 1 because we can always multiply anything times 1. Because like with this one, I could have taken it times 1, doesn't change anything. I could have taken it times 1, doesn't change anything. So if there's no 7, it's like there's just a 1 left there, all right, Gavin? Let me know you're still. Oh, he is still awake. Good deal. All right. So now we got to know about PEMBAs and we got to follow PEMBAs, okay? We need to evaluate these different things. So, what is the very first thing, Haley? I'm going to come back to you. What's the very first thing we look at when we do PEMDAs? We look at parentheses. So, we got to do these parentheses. And, guys, we're going to have to step these down. There are only, I think, 4 of these. No, there's 6 of these, but I need you to use paper on them. So, the first step 6 minus 4, Haley, is 2. All right, keep the parentheses there. We got the -3 plus, and then we've got -2 to the 0. All right, and we have to bring down the 5 minus. So it's do everything we didn't do. All right, then we need to focus on the exponents. So with this one, all right, with this one, 2 to the -3rd. We only focus on what's inside the parentheses. So that would be 1 over 2 to the 3rd. Do we agree? Yeah, that's what we've done. All right, this one. Now I'm going to test somebody out to see if they were paying attention. Let's go with Carson. -2 to the 0, Carson. Always and forever 1. All right. Now, if you are a person that likes to take the shortcuts, 1 over 2 to the 3rd power. What is 2 to the 3rd power, Carson? Let's just keep going with you. You're doing good. All right. It's 1/8. How did he get that 1/8, Christine? All right. Are you following that, Bruce, how he got that 1/8? Yep. All right. Now, Lucas, now we're down to here where it's just addition and subtraction. So how do I know? Do I do subtraction first, addition first? How do I do that, Bruce? Or not Bruce, Lucas? No. No. In this case, you were right. We do subtraction first, but not because it's subtraction, because we go left to right. Does that remember that? Is that coming back? All right. So 5 minus 1/8 is 4 and 7/8. All right. Now I need you to be honest. 4 and 7/8. Do you guys remember how I got there? So I made that whole 5 into 4. And then what did I turn that 1 into that I took away? No, I turned it into 8/8, right? Do you remember how I kind of borrowed for fractions? And why did I choose, Michaela, 8/8? Why didn't I do something like 10/10 or 7/7? Why did I choose 8? Whoa, whoa, whoa. Lucas, you're talking over us. I'm sorry, keep going, Michaela. Yep, the denominator was there. We wanted to borrow the common denominator, right? Oh, 4 and 7/8 plus 1. All right. So 4 and 7/8 turns into 5 and 7/8. All right. So go ahead and let me know in the chat how you feel about the borrowing there, or how you feel about this step right here. Let me know how you kind of feel. You can type in a 1, I don't got it at all. 5, I've got it pretty good. And I'll be on to do questions with those here in a little bit. Okay? So we've kind of seen there. I'm going to erase my work. We had 5 and 7/8, and let's watch their work real quick. All right? So parentheses first, just like Haley said. Then they focus on the exponents. All right? They got exactly what we got. Then we work left to right. All right? 5 and 7/8, they did it all in one step. All right. So I don't like how they show it all in one step. I'd like to show them. So, guys and gals, I need to see the work, and those are the things you got to add in the Google form. I need to see those steps out, line 1, line 2, line 3. I'd like to see a line 4 and a line 5 on those to get to the answer. All right. So let's move on to this next one. Now, Crew, let's go ahead and start with you, and then Natalie, I'm going to bring you in on the second step. Crew, you may still be muted. Focus on parentheses. 7 minus 4, is that 3? Yeah, all right. All right. So -2. All right. Now, I said second step for Natalie, but I meant later on. So plus -8/0. So, crew, you're going to go ahead and do these exponents with me. It's 3 plus. Now, let's focus on this exponent here, crew. What do I do with this one? Not -2. When we bring it to the bottom, it is no longer negative. It 3 to the second power. What's 3 to the second power? 9. All right, 3 to the second power. All right. So what about then it's plus, what is -8 to the 0 power? Anything to the 0 power is always and forever 1. All right. Now you're up, Miss Crondo. So what do we do first here, Natalie? Three plus. Oh, you can't tell. Oh my goodness. 3 plus 1/9 would be. All right, man, insulting my mouse writing, which probably needs to be done. So 3 1/9. Okay, plus the one. You guys can pin my screen too if you want to see it bigger. You go over it and hit the pin button. It's bigger. And then what's our final step there, Natalie? That should be 4 1/9. So 4 1/9 is our answer there. Okay. All right, I'm going to get rid of my writing and then show you kind of what they did there. Okay. So they did the parentheses first there. Then we did that. And then they did the addition. They got the same answer. I'm not happy just quite yet. All right. Let's look at number 4. All right. Now, number 4 is not much difference, but it does have a item to it. They added multiplication in, but we know how to deal with multiplication. All right. Plus 10 to the negative first. All right, Michaela. All right. What's the very first thing here we do with the problem I wrote in blue? What do we want to focus on first? Okay. Now, multiplication happens before addition. I agree with that. But before we can do the addition, PEMDAS, parentheses, what's the second thing? Parentheses, then the E stands for exponents, okay? So we always have to do those exponents before we can do that multiplication, all right? So if I think about this as 2 to the negative 3 over 1, what does that become, Michaela? No, we got to get rid of the negative exponent first. So what does that negative mean? We got to do the 1 over 2 to the third, right? Yep, 2 to the third, 2 to the third power. All right, so we still got the 4 there. Here we still have 10 to the first over 1. Do you see how the negatives just tells me take the reciprocal of those guys? Those, they look exactly the same. It's just the reciprocal, and now the exponent's positive. So 2 to the third power means what? It means what, Michaela? 2 to the third power. It means 8. 2 times 2 times 2, which is 8. So this one becomes 1/8. All right, plus, what does 10 to the first power become? How many times did they want the 10? 10. Nice job, Michaela. All right, now we've got a 4 over 1 times this item right here. All right, now what do we do, Michaela? You're doing so great. You want to keep going? All right, so we get 4/8, and we have 4/8 plus 1/10. All right, 1/10. All right, so then we need to get common denominators. Is it all right if I do one thing, Michaela? Everything you said has been spot on. I'm going to do a little reducing before I do that. So, I can divide 4 by 4. That becomes 1. I can divide 8 by 4. That becomes 2. I get 1/2 plus 10. Oh, now does it become a little easier to get our common denominators? What do I have to do to get our common denominators here, Michaela, then? You're doing great. Okay, we could do it that way. All right, 10 over 10. All right, so we get 10 over 20. All right, that'll work. And here times 2 over 2. Did I do what you said, Michaela? All right, and then we get 2 over 20. All right. So then we would get 12 over 20. And that would be our answer, or we could reduce that down a little bit. That would be a good answer. Or we could have taken this times 5 over 5 and had 5/10, and we could have got 6/10 as our answer, which that's what that reduces to. So it doesn't matter which way we do it. As long as we do it all the steps, we get the same answer of 6/10. You guys ready to get started? Yeah, all right. So let's work on 4-2. I am going to set a 15-minute timer. All right, so 15-minute timer is set, and I want you guys to be working on that. I will keep presenting my screen, and I will go over any questions with you. I'm going to get the video up for what we did. It took a little longer than I thought, but I think we're there. All right, so I'll be here for questions. See you guys.